Hello, today we're going to learn about equations with two variables. Previously, we've mostly talked about equations in one variable, so it might look like x plus 2 equals 5, and when we solve it, we would figure out that x equals 3. Or we might see something like, y divided by 2 equals 10. What's y? Well, y is going to be 20. Okay. Now when we're talking about equations with two variables, like x plus y equals 3, we can't really solve it in the same way because the value of x depends on the value of y, or the value of y depends on x, right? I can't say what's x and what's y because if x is 2, then y would equal 1. Or if x equals 0, then y would equal 3. Okay, so it all depends. And so we call these dependent and independent variables, which we're going to get into later. But what's important to note is that with an equation with one variable is solvable, like this or like this. An equation with two variables is not solvable. There's an infinite amount of answers, right? Because I can't just choose positive values for x. If I said x is negative 100, well then y could be 103, and that would still work. So there's an infinite amount of answers for an equation with two variables, but I'll show you how we use them anyway. So let's say, for instance, that you make $10 per hour at a clothing store. We can make an equation out of this. So your income, or the money you make, is going to be equal to that $10 per hour times the number of hours. So we might say I equals 10h. Okay, and then I might ask a question like, if you worked 5 hours, so if h equals 5, what is your income? Okay, and that's easy, you just plug it in. So your income is going to equal 10 times the number of hours you worked. So in this case, your income is $50, right? Or I might say, if you work for 12 hours, how much money do you make? Well, that's going to be 10 times 12. Alternatively, I could say something like, if you had an income of $60, how many hours did you work to get that? Okay, so you would say, well, 60 equals 10 times h. And then you could say, well, if we divide by 10, well, we worked for 6 hours. A lot of this, since I'm using a very simple example, is pretty intuitive, and I think you know how to solve these pretty easily. Here's another one. Let's say your car, or your family's car, can go 20 miles on 1 gallon of gas. So we can make an equation out of that. And the real-world equations model all sorts of real-world situations. Hundreds of thousands, millions of real-world situations are modeled and can be modeled by mathematical equations. And we can use those equations to make predictions and to answer questions. These are just very simple ones, but they can be super complicated and contain dozens or hundreds of variables. So your car can go 20 miles on 1 gallon of gas. So the distance your car goes is going to equal 20 times the amount of gallons of gas you have. So if you only had 1 gallon of gas, you could only go 20 miles. So I'll say D equals 20G. If you had 2 gallons of gas, you could go 40 miles. Right? 3 gallons of gas, you could go 60 miles. So again, we have these two variables, and depending on what one of the variables is, you can figure out the other. So let's say your car trip is going to be 200 miles. How many gallons of gas do you need? Okay, so 200 miles equals 20 times the amount of gallons. So we know that, well, we're going to need 10 gallons of gas. Okay. So using all that knowledge, oftentimes we're just given equations and we need to figure out solutions. Okay. So for instance, I might say, well, here's an equation, y equals 4x plus 5. Using -6, -2, 0, 2, and 6 as values for x. So we're going to use all these values separately. Find y, or solve for y, or solve. So what we can do is we can just do this separately a bunch of times. So first of all, I'm going to plug in -6. So 4 times -6 plus 5. So if x is -6, I know that 4 times -6 is -24. And then I'm going to add that 5, and so I know it's going to be -19. And so we can say when x is -6, y is -19. Then I would go on and try -2. So y equals 4 times -2 plus 5. And then I would solve it in the same way. So I know that when x is -2, y is -3. And so on. So let me do one more example. So if I say y minus, no, that's not the one I want to use. Oh, here we go. Y equals -x minus 1. So if I want to plug in, so if x equals -3, what is y? So I can plug in -3. So I'm going to say y equals, now keep in mind, x only, x itself is the -3. And so you could think of this subtraction sign or this negative sign out there as an opposite, right? So what is the opposite of -3? And so that could get tricky because x itself is -3, but -x, or the opposite of x, is going to be 3. And you can see that happening with the double negative there. So it's just 3 minus 1. And so y is going to equal 2. I think that's all we need for the video today, and we can get some practice in tomorrow. Thanks for watching.